Hi everybody, welcome to the explanation for the science test from the Princeton Review textbook, test number 3 out of 5. As always, as we go through these tests, it's not so important to memorize any answers because you're not going to see these questions ever again. But it's important that you look at how to answer these questions. When you see words in the passage, how do you connect them to the question? When you see the different question types, how do you approach the different question types? You don't know what will come up in your exam. You might get many long passages, you might get some equations, some graphs, but you will have covered most of the topics. So the more you practice, the easier your exam day will be. Let's have a look together. Question 1. Or what occurs when the Earth moves between the moon and the sun, resulting in a shadow cast over the moon? And the two options were a solar eclipse and a lunar eclipse. So let's think about what we have in the question. The Earth goes in between the moon and the sun. So if we have the sun and we have the moon, the Earth is in between. So as we read the passage, we need to think about which of those options, the solar eclipse or the lunar eclipse, happens when the Earth is in between the sun and the moon. From our perspective on Earth, two types of eclipses occur. Lunar, blocking the moon by the Earth's shadow, and solar, the obstruction of the sun by the moon. When the moon passes between the sun and the Earth, the lunar shadow is seen as a solar eclipse on the Earth. When the Earth passes directly between the sun and the moon, its shadow creates a lunar eclipse. When the Earth goes directly in between the sun and the moon, it makes a lunar eclipse. So the correct answer that we need is lunar eclipse. Remember, an eclipse is where something is blocked. Because of the position of the objects in a line, one thing is blocking out another thing. Even though the moon is small, if the moon is in between the Earth and the sun, and you are in the shadow of the moon, you would not be able to see the sun. Question 2. We have a formula question. When a car stops, there is 40,000 joules of work done by the brakes in a time of 5 seconds. So calculate the power of the brakes. Well, the power is equal to the work divided by the time. So power equals work over time. The work, if we look at the question, is 40,000 joules. So 40,000. And the key thing here, when you have formulas, we have the work done, and this is in joules. And the 40,000 has the J next to it. So we can match the units to the explanation of the formula. By matching the units, it's much easier to put the numbers in the correct place. It's also good to check the units because sometimes we might have a formula that uses, for example, kilometers and a number that's using meters. So sometimes we have to change the numbers because they're in the wrong units. So checking the units is a very important step. Write down the formula first. Second, check the units. Third, put the numbers into the correct place. The time is measured in seconds. And we can see here we have 5 seconds. So this is 40,000 divided by 5. 40,000 divided by 5 is 8,000. So you should have written 8,000 in the box. Number 3. Which of the following indicates the correct order of the 4 stages of mitosis? And the answers are looking at telophase, metaphase, prophase, and anaphase, but in different orders. So let's look here. We have the prophase going into the prometaphase, which goes into we can see the arrow there, into metaphase. The arrow then comes down and starts to go along here. We can see the arrowhead. So anaphase is next, and then telophase, and then finally we have the cytokinesis. The cytokinesis is not listed in the question, but cytokinesis means the separation into different cells. And so it starts with prophase, prophase. So we have option C and option D. A and B, starting with telophase and anaphase, cannot be correct. For C, the next one is telophase, and D, the next one is metaphase. Well, we have the prometaphase in this passage, in this diagram, but that's not in either of the lists. The lists are in the more simplified form. And so after prophase, if we ignore the prometaphase, we go to metaphase. So metaphase is D. Then we have the anaphase, which again is in D, and the telophase, which again is in D. So this means that D is the correct answer. Now, independence and dependent variables do come up in the exam. The new GED curriculum that came out in 2014 is majority looking at the scientific method. You need to be able to identify what is the independent variable and what is the dependent variable. The independent variable is always the thing that the scientist wants to change. And the dependent variable changes because of the independent variable. There is a correlation between these two. There's a link between these two. The independent variable affects the dependent variable. The dependent variable is the outcome. It's what happens because of what the scientist did. The dependent variable is what is measured. So these words, the outcome, the effect, what's measured, they will help you to find the dependent variable. For the independent variable is what the scientist changes, what the scientist chooses, what the scientist varies, or the different conditions at the beginning of the experiment. So the four options are pepsin, rate of reaction, temperature, and catalyzation reaction. A student wants to know how temperature affects the rate of the catalyzed reaction. Temperature, I see that word affects the rate of the catalyzed reaction. So temperature and rate of catalyzed reaction should be the independent and the dependent variable. For the stomach acid pepsin, she sets up an experiment in the lab using reaction chambers set at varying temperatures. Varying means different. So she is choosing different temperatures. There are various temperatures. The person doing the experiment is choosing the temperature. So this has to be the independent variable. We're looking at the effect on the rate of reaction. The effect on something is always going to show you the dependent variable. So we are looking at the rate. We are looking at the rate of the catalyzed reaction. So the rate of reaction is the dependent variable. This is what is being measured. This is what is being counted, if you like. So in this question, we are asked about the three types of heat transfer: conduction, convection, and radiation. And we need to label two of these hands, two of these heat transfer. We have one box here, and we have one box here. Well, conduction is the process which heat transfer takes place between objects by direct contact. We can see here there is direct contact between the metal bar and the hand. So conduction should be raised up to here. Convection refers to heat transfer in which the transition occurs within the fluid. Now the fluid can be liquid or gas. It means that hot air or hot liquid rises up, it cools and falls down. Radiation is when heat is transferred without any physical contact between the objects, and this happens in waves. So heat that comes out like this would be radiation. We think about the heat energy that comes from the sun, the solar radiation, the UV radiation. So both convection and radiation can happen in the air. But what is happening here? Well, firstly, look where the hands are. The hands are at the side. If the hands were above, the hot air would be rising up. That's why there would be radiation. But the hands are not above. The hands are at the side. Second, look at the arrows. They are the wavy arrows. It's not the rising and falling, it's the wavy arrow. So the correct answer is radiation. Now we're on to these typical questions where we're looking at genetics. Heredity involves the passing on of traits from parents to offspring. The trait is considered dominant if it always expresses itself, provided that at least one copy is present. A trait is recessive if it needs an exact copy in order to express itself, if you need 2 copies. In humans, each parent contributes 2 genes per trait to the pool of genes available. The contributions can be homozygotic, both dominant or both recessive, or heterozygotic, one dominant and one recessive. Scientists use the Punnett square to work out the likelihood of various traits. Now, that is not new. For a question like this, we need to know some key information. Freckles are dominant. Not having freckles is recessive. So we have 2 parents here. The egg cell, so the mother is at the top, and the sperm cell, so the father is at the side. Which of the following is the most likely description of the parents contributing genes for the results displayed in this Punnett square? So here, all of them on this side have a capital F. So this must be capital F. We can also look at here, and we can have a small f. So that would leave a capital F for the father and another capital F for the father. So the father is homozygotic dominant. The mother is heterozygotic, but she would have freckles. She would have freckles because she does have one dominant allele. So both parents would have freckles. They would both have, because one has the dominant gene, 2 of them. The other has one dominant and one recessive, but because freckles are dominant, the freckles will show themselves. So answer B is correct. Freckles are a dominant trait. Not having freckles is a recessive trait. What is the probability that the child of one heterozygotic parent and one homorecessive parent will have freckles? Now, be careful. This question has a heterozygotic parent and a homorecessive parent. The Punnett square over here was a homozygotic dominant parent. So this is not from the Punnett square. The heterozygotic is here, and then the homozygotic down here. So the heterozygotic would give the dominant allele, or it would give the recessive allele. But the other parent would always give a recessive allele. So these 2 offspring would have 2 recessive alleles. So they would not have freckles. These 2 offspring would have one dominant allele, and one recessive allele. And because freckles are dominant, that would be enough. They would have freckles. So 2 of the offspring not have, 2 of them do have. This means there is a 50-50 chance for having freckles or not having freckles. When you get a question like this, you might know the answer already, but the best way to answer a question like this is to draw a Punnett square. As long as you get the parents' alleles correct, you should be able to work out the chance of having or not having a trait. Now we're going to use this formula. Newton's law of gravity states the gravitational force that 2 objects exert on each other is the force of gravity is equal to the constant times the mass of the first object times the mass of the second object divided by the distance between the objects squared. If means imagine. Imagine the mass of one object is doubled and the mass of the other object is reduced by half. The gravitational force will do what? So let's just put in some numbers. So the force is equal to the constant. So let's say the constant is 1 times, at the beginning, let's have 2 and 2 divided by, let's say the distance is 1 because we can work with this number very easily. So 1 times 2 is 2 times 2 is 4 divided by 1 is 4. Now, we're going to do the imagined situation. So in this situation, the constant is still going to be the same and the distance is still going to be the same, but we're going to change 2 of the masses. One object is going to double. So 2 is going to double. This will become 4. The other object will be reduced by half. So instead of 2, this will become 1. Well, 1 times 4 times 1 divided by 1 is still 4. If one object is doubled and the other object is reduced by half, there will be no change. The two effects will cancel each other out. You might be able to see that just by reading the question. You might be able to imagine that if you double one number and you halve the other number, then you're not going to have a change. Doubling and halving will cancel each other out. However, if you cannot see that by reading, then put some numbers in and do the equation. By putting numbers in, you don't need to imagine anymore. You can see for yourself what the effect will be. Whether a substance is classified as acidic, basic, or neutral is determined by the pH. A pH below 7 is acidic. So white sugar, coffee, brown sugar, vinegar, and lemon juice are all acidic. pH of 7 is neutral, and above 7 is basic. So the baking soda and the dishwasher soap here are basic. What is the average pH of, now let's read carefully, all the basic substances to the nearest 10th? We're not asked what is the average of everything in this table. We're asked what is the average of the basic substances. The basic substances are the baking soda with a pH of 8 and the dishwasher soap with a pH of 12. So this would be 8 plus 12. We want the average, so we divide by 2. So the correct answer is D, 10. Which of the following can be properly inferred from the passage? Now, Inferred, remember, means something that is not stated directly, but there must be some clues to support the idea. Anything that has no support, that has no link to the passage, cannot be an inference. Anything that is false cannot be an inference. Anything that is stated directly by the passage cannot be an inference. So when we get a question that asks which of these can be inferred, we need to read the answers carefully, and then we need to try and find some of the answers in the passage, or see if any of the answers are refuted by the passage. So answer A, before the early 20th century, there were well over 1 million black rhinoceroses alive. B, there are only 2 living subspecies of black rhinoceros. There are no more black rhinoceroses alive, or man contributed to the demise of the West African black rhinoceros. Let's look at the passage. It is estimated that in the early 20th century, 4 subspecies of black rhinoceroses roamed the African savannas. These 4 subspecies, roughly 1 million animals. So before the 20th century, there were over 1 million. In the early 20th century, there were roughly 1 million. This seems to be stated by the passage. By the early 2000s, though, 1 subspecies had gone extinct. 1 species had gone extinct. So there were 4. 1 becomes extinct. So 4 minus 1 means there are 3 living species. Answer B says only 2 living species. I think that might be false. And the remaining 3 had a total combined population of fewer than 2,500 rhinoceroses. The West African black rhinoceros was one of 3 subspecies of black rhinoceros that survived into the early 2000s. While it had formerly roamed several countries towards the southeast region of Africa as early as the 1980s, its range had shrunk to only 2 countries, Cameroon and Chad. At that time, the total population was estimated to be fewer than 100 animals. By the late 1990s, it was estimated that fewer than 10 remained. Of those 10, 6 lived in total isolation, nowhere near to each other, and therefore unable to mate and carry on their species. Why? Why did the number go down so much? Answer D says that man contributed to the demise. So, you need to think about that. There were many factors that contributed to the demise of the West African buffalo. Many factors. Some sports hunters sought the animals. Industrial agriculture also played a role, as the humans cleared rhinoceros habitat for fields and settlements. Farmers and ranchers largely viewed the animals as pests. Others believed that the rhinoceros horn was a cure for many ailments, including cancer. Sadly, the last West African black rhinoceros was seen in 2006. The species was officially declared extinct in 2011. Well, if the species was extinct in 2011, that means that there are not 3 left anymore. There are now only 2 left. So B actually is not false. Now D, man contributed to the demise. Well, it does say that the sports hunters sought the animals. And it does say that the humans saw them as a pest. The farmers viewed them as a pest. And the humans cleared their habitats. And that the rhino horn was used as a cure for many illnesses. Now, the passage does not say that people killed the rhino. It says that sports hunters would go after them. It says that the area was cleared. It does not say directly that men killed the animal. So this would be the best answer. It is inferred, it is suggested that men had a bad impact on the rhino, but it is not stated directly. The problem with answer B is that although we now know that this species was declared extinct in 2011, so that would leave only 2 left, we don't know about the other 2. This passage does not give us any information about the other 2 species. They might also be dead. If they are also dead, then there might be none left. So C could be possibly true. There might be no more black rhinoceros. If all the rhinoceroses are dead, then C could be true. But B and C are both could be, possibly. This passage is about the West African black rhinoceros. We do not even know the name of the other species. So B and C are not supported. That's why D is correct. Scientists hypothesize the powdered rhinoceros horn is not actually a cure for any human ailments. What information does this passage offer to support or refute this hypothesis? So scientists think that this is not actually a cure. Where does it talk about the horn? Well, here. Others believe that the rhino horn was a cure for many ailments, including cancer, which resulted in poaching. We are not given any reason for that. We are told that some people believed that it cured these illnesses, but we are not told why. Why did people believe that it cured these illnesses? Therefore, this passage does not give any information. This passage provides no information to either support or refute the scientist hypothesis. Support means agree, refute means disagree, but there's no information there. Answer A, the passage provides information about what ailments the rhino horn may cure. Well, it does tell us that it may cure cancer, but the idea there is may cure. Not it does cure, not there's been a test, not these people recovered. It's may. May is not evidence. May is a possibility. So that's why A is wrong. C, the passage provides information about other reasons that humans killed the rhino. Well, other reasons are not about the cure for human ailments. Ailments means diseases. So C is not correct. D, the passage provides information about other reasons that humans killed the rhino. Well, again, other reasons is not helpful. Other reasons do not link to the idea of human illness. So it's true that there are other reasons, but the other reasons do not support or refute the hypothesis because the other reasons have no link to the hypothesis. So when we're trying to support or reject a hypothesis, we need to be talking about the same topic. So the only answers that you could really choose would be A, which talks about the ailments, or B, there is no information. C and D talk about different reasons, not the human ailments. Let's have a question. We need to complete the drop-down boxes, and I've just opened them up for you so you can see what options we have. When ice melts into water, bonds between the molecules are what? Created or broken, which results in heat being what? Absorbed or released in what is called a endothermic or exothermic reaction. So the ice is going to melt into the water. What we need to know is, are bonds created or broken? Is heat absorbed or released? And is it endothermic or exothermic? So when an endothermic reaction takes place, bonds between the molecules are broken. The process of breaking apart the molecules requires energy, so heat is absorbed from the surrounding environment. However, when an exothermic reaction takes place, the bonds are created between the molecules and they want to stay together, so it requires less heat than the process of breaking the molecules, so heat is released. So we can see that exothermic will be with the idea of creating the links and heat being released. Or we can have an endothermic reaction where heat is absorbed and the bonds are broken. So ice melts into water. Why does the ice melt? I think the easy way to do this is to ask, is heat going in or coming out? Let's start with this box in the middle. Is heat going to go in or come out? Well, if the ice is melting, the particles are getting more energy. That's why they can move around. That's why it becomes a liquid. So when the ice goes into the water, the ice is going to absorb energy, absorb heat from the water. So absorb. Now, by reading the passage, we can see that if we're choosing absorb, then it must be an endothermic reaction. And in an endothermic reaction, the bonds between the molecules are broken. Which of the following answers gives an explanation for the temperature of the breaks? Thermal energy was converted into kinetic energy. Kinetic energy became potential energy. Potential energy became kinetic energy, or kinetic energy became thermal energy. Now, we're looking for an explanation of the temperature of the breaks. After driving to school, Marty notices that the brakes on his car are hot. So after driving, the brakes are hot. So we will need thermal energy at the end. Now, when the car was driving, the car had kinetic energy. The brakes stopped the car from driving. So the kinetic energy, the moving energy of the car, became thermal energy, became heat energy. So the correct answer is D. When the brakes rub against the tire rim, what generates heat via thermal transfer? And we have the option of friction, radiation, or conduction. When Marty touches the brakes with his hand, he feels the heat via radiation, conduction, or convection. So, in physics, an object's kinetic energy is the energy it possesses due to its motion. An object's potential energy is the energy it possesses by virtue of its position. So potential energy is about the position, kinetic energy is about the moving. And its position or the electrical charge or the stress or other factors. Thermal energy does not have anything to do with whether an object is stationary or moving. Instead, thermal energy is the energy that comes from heat, which is generated by the movement of the particles in the object. So it's still a part of kinetic energy, but it's the kinetic energy of the individual particles, not the kinetic energy of the whole thing. The faster the particles move, the more heat is generated. Heat transfer occurs in three primary fashions: conduction, convection, and radiation. Conduction describes the transfer of energy when objects are physically touching. So with the hand, he feels the brakes. So this must be an example of conduction. But let's continue. Convection is the energy transfer of an object to the environment, and radiation is the transfer of energy via electromagnetic waves. I think we can take away radiation. Now, it's true that the brakes do touch the tire, so it could be conduction. But we see that word against. Against might mean in opposite directions. So if you rub your hands together, maybe one hand comes towards you, one hand goes away from you. Your two hands are moving against each other, and that creates friction. If you rub your hands together very quickly, you'll get heat energy. Heat is always produced when objects have friction, when the objects move against each other. So the correct answer for the first one is friction. GnomePro collected a video in flight of two asteroids colliding. So two asteroids collided. According to the video and the accompanying data, asteroid Alpha, which had a mass of 750 kilograms and is traveling at 20 kilometers per second, struck asteroid Omega head on. Omega had a mass of 500 and was traveling at 25 kilometers per second. Which of the following would not be true of the collision? Now, when two objects collide, each of them will bring momentum into the collision. So if two objects come together, each of them has momentum. After they collide, the momentum will add together. So both asteroids had momentum coming into the crash is true. And that results in energy that will be transferred to the other asteroid on impact. We have two asteroids that are coming together. This one will be hitting this. This one will be hitting this. They will both be getting energy from each other. This is true. And we're looking for the answer that is not true. B, the asteroids had no inertia as they crashed since the impact occurred in space. Inertia can happen in space. Inertia means no change. When the objects crash into each other, there would be a change. We might come back to B. C, since energy cannot be created or destroyed, true, the energy at the impact from inertia and momentum would cause an explosion of shattering pieces of the asteroid. Bits would explode. If you get two rocks and you hit them together at high speed, then one rock might crumble. There might be an explosion. C is also a true answer, so we remove it. As the impact occurred, the smaller pieces of the asteroid were propelled into their own asteroid orbits. If this one broke into smaller pieces, then each piece would have gone into its own orbit. This is true. So the correct answer is B. Objects can have inertia in space. For the next two questions, we're given two sources of information. There's a short paragraph and a diagram. And we're asked firstly, according to the food web, grasshoppers are, and we're given the options of carnivores, omnivores, or herbivores. And monkeys are, and we have the options of carnivore, omnivore, and herbivore again. Now, the first thing that we need to do is look for the grasshopper and look for the monkey. This little thing down here is the grasshopper. This thing is the monkey. If you don't know what carnivore, omnivore, and herbivore are, then we can read the passage. You might already know what these words mean. In the real exam, you might get something that you don't know what it means. and you'll have to read the passage. And then you put the definition together with the picture. So, animals that only eat plants are called herbivores. Animals that eat both plants and animals are called omnivores. Animals that only eat other animals are carnivores. So if we look at the grasshopper is only eating the grass. The grass is a plant. So the grasshopper is a herbivore. Then we look at the monkey. The monkey is eating what looks to be a snake, and the monkey is eating the grasshopper. But there are no plants going into the monkey. So according to this diagram, not according to our own knowledge, but according to this diagram, the monkey is only eating other animals. So the monkey is a carnivore. It's not an omnivore because there are no arrows going from the food of the plant into the monkey. Now, if you chose omnivore, that means you used your own knowledge. I think most of us know that monkeys do eat plants, whether it's bananas or nuts or rice. If we've been to Zwikkerbin, then we see monkeys eating plant food. But we do not use that knowledge when we take the exam. When we take the exam, we base our answers on the passage, and in this diagram, the monkey is only eating animals. Next, which organisms in the food web are secondary consumers? What's a secondary consumer? Well, we have, firstly, the plants, and the plants are the producers. And then, after the producer, we have animals that eat the plants, and they are the primary consumers. And then we have animals that eat both plants and animals, and they are secondary consumers. So, if we look at these four animals, the giraffe is only eating the tree or the plant. So the giraffe would be a primary consumer. The rhinoceros is also only eating the grass and the plant. So that would also be a primary consumer. The bird. Now, we don't have a clear bird, but I think this is supposed to be a bird here. And this bird is eating the cricket, and the cricket was eating the grass. So the cricket is the primary consumer, and the bird is the secondary consumer. The mouse, like the rhino and the giraffe, is only eating the plant. So the correct answer, according to this information, is bird. Based on the diagram, it can be inferred that most human activity takes place where? Well, this is the surface of the Earth, and next to the surface of the Earth, we have the troposphere. If we look at the passage, the troposphere is the layer closest to the Earth. It contains about 80% of the mass of the entire atmosphere, and it is about 10 kilometers deep. Most human activity would take place in the troposphere. People live and walk on the surface of the Earth. They have their houses on the surface of the Earth. They fly in planes. And the planes would be probably not more than 10 kilometers above the surface of the Earth. So the correct answer is the troposphere. According to the passage, which layer of the atmosphere likely has the least presence of UV rays? And we have the troposphere, the stratosphere, the mesosphere, and the thermosphere. So I can see UV rays is here, so I probably want to start reading around here. The stratosphere is where the ozone is located. So the stratosphere is where the ozone is located. The ozone layer helps to prevent UV rays from entering the atmosphere. So UV rays come in, and the UV rays hit the ozone layer, and the ozone layer prevents the UV rays from going through. The ozone layer helps to prevent the UV rays from entering the atmosphere. Now, the atmosphere here means the Earth's surface. It means the layer of the Earth close to the surface. So we have plenty of UV rays coming through the exosphere, the thermosphere, the mesosphere, but when they hit the stratosphere, they get absorbed by the ozone layer, which means only a few rays would come through the stratosphere to the troposphere. Most of the UV rays would be absorbed. So the troposphere is where there will be the least presence of UV rays. If most of the rays are absorbed in the stratosphere, then anything below the stratosphere will have less. Now, actual mechanical advantage defines as the force that a machine can multiply while taking into account the effort lost to friction. The formula used to calculate the actual mechanical advantage is shown below. The AMA equals the output force divided by the input force. So the boulder on the road requires an output force of 4,000 newtons to be moved. There needs to be an outward 4,000 newtons to move it. The engine creates 250 newtons. Now the engine is putting force in to the action. So the engine is putting in 250 newtons. But the engine is able to move the boulder. So what was the mechanical advantage? Well, it is 4,000 divided by 250, which is 16. The mechanical advantage is that the force is multiplied by a ratio of 16. So it's 16 times higher by using this machine. For question number 21, we have a question based on a passage and on the pie chart. Now it says based on the pie chart here and the information here, which the following can be inferred, which can be guessed about the use of fuels in the United States. A, the United States is not concerned about greenhouse emissions. Well, coal is 38%, natural gas is 27%. So these are both big on greenhouse gases. If you look at the disadvantage of coal is it emits greenhouse gas. So A, possible. You might argue that they don't care about greenhouse gases because they have such a large percentage of their electricity generation coming from fossil fuels. B, the United States predominantly uses an efficient, inexpensive energy source that poses danger to the people involved in making the source available to the public. While coal is the largest section, coal is inexpensive, coal does have danger for the miners. Miners being people that have to go down under the surface to get the coal out. So B is also possibly there. C, the United States is focused on using energy sources that pose no danger to humans. Well, nuclear, they are dangerous if there's an accident. Coal, there is a danger for the miners. And nuclear is a large portion and coal is a large portion. So both coal and nuclear have dangers, and between them, they have almost 2/3 of the energy in America. So they do use many types of energy that are dangerous. So C is definitely not correct. And the United States is not concerned with finding new ways to utilize renewable sources of energy. Well, renewables is only 13.2%. Are they concerned about it? Yes or no? Well, the simple answer is we don't know. By looking at this pie chart, we can see that 13.2% comes from renewable energy. Now, if 2010 it had been 1% and it increased to 13%, then you could say that they're putting a lot of energy into it. If it had been 13% in 2010 and 13% still in 2014, then there's no change. So they're not putting any energy into it. There's no evidence to support whether people in America are trying to increase their utilization of renewable sources or not. We don't know if they are finding new ways. We don't know if they are increasing the use. So C and D are removed. We need to think carefully about A and B. The United States is not concerned about greenhouse gas emissions. Now, again, that is a little bit too broad. We don't know. If coal and natural gas used to be a lot higher and now it's reducing, then that might be evidence that they do care about greenhouse gas emissions. But if it's stayed the same, then that would be evidence that they don't care about greenhouse gas emissions. Simply, we don't know. B can be supported by the information that we have. Predominantly means mostly. Mostly they use coal. The largest section is coal. Yes. Coal is inexpensive. Yes. Coal poses danger to the people involved in making the source available to the public, while dangerous work environment for the miners. Yes, there is a danger for people who are mining. The people that are mining are the people making it available to the public. So B is the best answer. According to the pie chart, what percentage of electricity came from non-renewable sources of energy? Non-renewable sources of energy. So this is percentages. So we want to know non-renewable. So if we have 100 and then we subtract renewable, what we have left will be the non-renewable. Now, don't be confused. Nuclear is an example of non-renewable fuel. Once the nuclear fuel is being used, once it's being broken down, the energy is being released, it cannot be used again. There is a lot of waste that has to be stored somewhere. So nuclear is an example of a non-renewable fuel. The renewables are here, 13.2%. So 100 minus 13.2 would give us the answer 86.8. So the correct answer is 86.8. You don't need to write the percentage, you only need to write the number. Which of the following can be properly inferred, again inferred, from the information presented in the map and the passage? A. Volcanoes are always located towards the edge of the continent. Are they always there? Well, the Ring of Fire is an area that surrounds the basin of the Pacific Ocean where a significant number of earthquake and volcanic eruptions occur. And then later on it says all but 3 of the 25 biggest volcanic eruptions have occurred in the Ring of Fire. All but 3. That means 3 of them, 3 of the 25 biggest, were not there. Some of the volcanoes are not there. There is the significant area. It is an important area. It's where the majority of them are, but not always there. Always is too strong. So we can take away answer A. Volcanoes are equally distributed between the eastern and western hemisphere. Well, we do have the eastern hemisphere, we do have the western hemisphere, but we don't know exactly how many volcanoes are in the east, and we don't know exactly how many volcanoes are in the west. We have this horseshoe shape because this is the edge of tectonic plates. So we can take that away. Volcanoes are commonly found between the boundaries between tectonic plates. Well, it says that this phenomenon is the result of plate tectonics. The eastern part of the Ring of Fire resulted from the Nazca Plate and the Coco Plate being subducted under the South American Plate. So the Nazca Plate and the Cocos Plate are subducted. That means they are pushed under the South American Plate. And then the northern portion is the result of ongoing subduction of the Pacific plate. The Pacific plate is going under the Aleutian Island arc beneath. Oh, so it's the Aleutian Islands arc and to the west. The Pacific plate is being subducted under the Kamchatka Peninsula arc. So they're going under different plates. To the east, to the north, to the west, one plate is going under the others, and that's where we're getting the volcanoes. So volcanoes are commonly found along the boundary between two tectonic plates. This is something that we can assume by looking at the information and by looking at the map. D, the location is completely random. Well, 90% of the earthquakes and 452 volcanoes are in this area. Why are they in this area? Because this is where two different tectonic plates are meeting and where one plate is going under to be subducted under the other plate. So they are not random. There is a clear pattern. Question 24. Which of the following can be concluded from the graph above? It's not a very clear graph, I'm sorry. In a real GD exam, I think you would have a color graph. Each of these lines would be a different color, but we do have KNO3 here, NH4Cl here, the CuSO4 is there, and the HgCl2 is there. So the solubility varies directly with the temperature. So varies directly means there is a pattern. Directly means they both increase. So as the temperature increases, the solubility also increases. And we can see that on all of these lines, they are all going up at the same time. So on all of the lines, as the temperature increases, the solubility also increases. So A does look like it could be a good answer. B, at 40 degrees Celsius, so we're looking here, KNO3 and NH4Cl have the same solubility. Well, 40 degrees Celsius is this line. KNO3 is here. Let me do the highlighted pen, it'll be easier to show. KNO3 is here, and NH4Cl is here. They don't have the same solubility. One is a little bit over 40, and one is just over 60. They have different solubilities. B is definitely false by looking at the graph. And something like this, we are looking to try and remove any answer that is false. And if we can find the answers that are false, then we are more sure about the answer that we choose. C, the solubility of mercury chloride is 80 degrees Celsius is 20 grams per solute. So mercury chloride is here. At 80 degrees Celsius, it is a little bit over 30. It is not 20 grams, it is a little bit over 30 grams. So answer C is also proven to be false by looking at this graph. And then D, there is no consistent relationship between temperature and solubility. No relationship might mean like this. One goes up and down, go up and down, go up, go down. They're inverse, direct. That would be kind of a no relationship. Or if you have a scatter plot, you might have something here and here and here and here and here. That would be no relationship. But on this graph is very clear. On each of the lines, they are generally going up. As the temperature increases, the solubility also increases. So we can say that there is a direct relationship. They are directly correlated. There is a positive correlation. Answer A is the best answer. So B and C are details that are proven false, and D does not match the general pattern that we are seeing on the graph. Question number 25. Based on the figure above, if the deer population decreased, so the deer population decreased, where is the deer? The deer is here. If the deer population decreased, it would be reasonable to conclude that the tick population would increase, decrease, or stay the same. So let's follow this around. We have an egg. This egg becomes larva, and the egg, when it hatches, it lives in the mouse. Then, through fall and winter, it becomes a nymph, and it still lives in the mouse. We have the male and the female, and they come to live on the deer. So the tick is living on the deer. The tick is a parasite. We know parasites that live on dogs and cats. If you've ever had a pet, you probably remember picking off the ticks from between their paws, out of their ears. There will be ticks that live on the body. Well, it's exactly the same on the deer. The ticks live on the deer. The deer is the host and the tick is the parasite. So if the host dies, the tick population would decrease because there is less habitat, there is less food, there are less opportunities for the tick to live. Number 27. The central dogma of molecular biology was first presented by Francis Crick in 1956 and is an explanation of the flow of genetic information within a biological system. Simply put, the dogma states that DNA makes RNA and RNA makes protein. Now, this is basically just an English question. X makes Y. So, Y is made from X. Yeah. The body is made, carbon makes the body is made from carbon. Think about food. Jojo makes the curry is made by Jojo. So we understand the idea of being is made from or is made by. It's making it into the passive tense instead of the active tense. So protein is made from RNA and RNA is made from DNA. So in the first box, we would say protein. Protein is made from RNA and RNA is made from DNA. I don't think this is a very realistic question for the GED. This is just more of a basic English exam. And the problem that we do have when we're practicing for the GED is that many of these practice exams have a real mix of questions. They have some really good questions that help you to prepare, and they have some questions that are either too easy or just not similar in style to what we would expect in the GED. This is one of those types of questions that we would not expect it in the GED. If you got this wrong, don't worry too much about it. This was more of an English exam or a basic knowledge or logic. This is better. According to the graph, what is the approximate carrying capacity or the number of organisms an ecosystem can support? Well, 5,000 would be around here. When it is 5,000, it goes up. It goes up. It is not going to be 5,000. That is definitely too low. 9,000 though would be around here, just below here. When it is 9,000, it starts to go down again. Here it's going down again. 9,000 is too high. So we need something that is either 7,000 or 8,000. So 7,000 would be here. 8,000 would be here. Which one do we think is the carrying capacity? Now, normally, carrying capacity graphs go something like this. You kind of get a horizontal line, and that horizontal line is your carrying capacity. If we look at this graph, we never really get carrying capacity. Okay, so we have to think, where is the average? Well, here, and then around here, coming back up to here, when it is only 7,000, it starts to come up again. it can support more than 7,000. We see 7,000 again here. Every time it goes down to 7,000, it goes back up. So 7,000 would be below the carrying capacity. The best answer for this question would be answer C. It seems to come to 8,000 more times. We can see here, 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 and it's coming back to 8,000 here. If we had to take an average, the best line would be on 8,000 rabbits. And the thousands come from the title. Whenever you look at a y-axis, when you look at the units, make sure you know what the units are in. Now, geothermal energy is extracted from naturally occurring steam, hot rock, water, or rocks in the Earth's crust. It is used to heat buildings and generate electricity in areas where hot magma, melted rock, is close to the surface. If you've ever been to Makassar, the hot springs in Thailand, that's an example of geothermal energy. The steam is coming up from below the surface. Some places they manage to harness that energy to turn the blades of a turbine and generate electricity. So which of the following places is geothermal energy most likely to be used? Well, it is extracted from places where there is naturally occurring steam, hot water, or rocks in the Earth's crust, and where hot magma is close to the surface. So Arizona is a state with abundant sunshine. If there's a lot of sunshine, why would they use geothermal energy? They could use solar energy instead. There is no need to try to use geothermal. Cape Cod is a peninsula. Peninsula means a rock formation formed from glacial deposits of sand. Glacial, well, we're thinking maybe like snow, and there is sand there. It's going to be deep, it's going to be far under the surface, it's going to be difficult to access any of the naturally occurring steam. Saudi Arabia, you might think the Middle East, the desert, that's going to be a hot place, that might be a good option, but they have a lot of natural oil and gas reserves, so they don't need to use geothermal energy. They have a lot of fossil fuel. But Iceland is an island nation with active volcanoes. So because of the active volcanoes, this would be where melted rock is close to the surface. So that's why answer C is correct. We are matching the idea of the active volcano and the melted rock being close to the surface. If there's no melted rock close to the surface, there would not be a volcano. A volcano is where molten rock comes to the surface. Which of the following is an example of artificial selection? Well, what is artificial selection? If we look at the passage, artificial selection is in the second paragraph. So let's start with that paragraph. Artificial selection describes the targeted, intentional reproduction of individuals in a population that has specifically desirable traits. In any species that reproduces sexually, for example, two adults that have a desirable trait are bred together. This often happens with racehorses. If you have a female and a male racehorse that are both very quick, you might want to breed them together to try and get offspring that are also very quick. So A, lizards with long legs that can climb better to reach food and avoid floods. Well, that might be an example of natural selection. Natural selection is the idea where organisms that are well adapted are more likely to survive and reproduce. This is not artificial. Intentional reproduction means man-made or artificial reproduction. Artificial means man-made. So the choice is made by men, not by nature. B, bacteria that adapt to previously fatal antibiotics and produce offspring that are also resistant. Well, this would be an example of natural selection. They naturally evolve to become resistant to the antibiotics. People would not want to make bacteria that cannot be killed. That would be bad for our health. So it's not going to be a choice that people would take. C, rodents, which means rats or mice. that migrated to a sandy environment, changed color from black to light brown to better blend in with the sand. That again is an adaptation. If their fur changes color, then the animals that eat them will not be able to see them as easily. And so they would be better adapted, they would be more likely to reproduce. So there would be, over time, a change in the gene pool. But that would be an example of natural selection. Dogs that are bred specifically to hunt large game are bred. Dogs are bred. That means dogs are put together to reproduce. Humans choose a male and they choose a female. And they're going to hunt large game. Large game means maybe deer or even, I don't know, in the wild, maybe lions or tigers. But they're going to hunt a large animal. So people might want to choose dogs that are fast, that are big, that are strong, that have good bone structure. People might choose a male and a female that are both good hunters and make them have children to hope that the traits would be passed on to the offspring. That would be an example of people choosing to make them reproduce. So an example of artificial selection. Thoroughbred race horses resulting from careful selective breeding. Well, careful selective breeding is about men choosing. And these are race horses. The owners want to win the race. They want to get the prize money for winning the race. So they choose horses that are strong, that are quick, that have good bones. This is an example of artificial selection. They are chosen because of their desirable traits, because the owner wants to have offspring that are likely to win races in the future. So when a car won't start because the battery is dead, what is the most likely explanation of what has happened to the original charge? The charge disappeared. The charge was converted into energy to power the car. The charge was destroyed. Or the charge leaked out of the battery. The law of conservation of energy states that energy can neither be created nor destroyed. Energy can never be created or destroyed. So we can definitely take away answer C. Energy cannot just be destroyed. And the idea of just disappearing, well, that's not a very scientific explanation, is it? Disappearing means it's not there, but an explanation would be why? Why is the energy not there? So we can take away answer A as well. And then the law of conservation of matter states that matter can also not be created or destroyed. So really, the choice is between answer B and D. The charge was converted, past tense, was converted into energy to power the car, or the charge leaked out of the battery. We sometimes talk about batteries leaking, but it's not a scientific explanation. The scientific explanation would be that energy is converted into a different form. Energy can't be created, energy cannot be destroyed, it only changes form. So the chemical energy that was in the battery had to be changed into some other type of energy. So if it was converted into energy to power the car, and then the battery did not recharge, then the battery would be empty. So if you've got an old battery, sometimes you have a problem. Sometimes the battery does not charge up again. Maybe there's a loose connection. Maybe the power cell is damaged. Maybe it cannot charge up. In this case, you have to get a new battery because the battery would be using its power, using its chemical energy to power the car. But once that chemical energy is gone, it does not store up any new energy. So answer B is correct. Hopefully you got that just by thinking about energy cannot be created or destroyed, so it cannot be C, and disappear is not really a scientific explanation. Leaking out is also not really a scientific explanation. We want to know, where did that energy go? What happened to it? Luke is conducting a survey to determine how effective his high school's ban on vending machines has been in reducing the amount of junk food that students eat. The survey asked students how much junk food they used to eat and how much they eat now. So in a school, they used to have machines that sold food, like chocolate, crisps, Coca-Cola, Fanta, those kind of machines where you put money in and the food come out of the bottom. The school banned those vending machines. That kind of machine is called a vending machine. Vending just means to sell. So the school banned those vending machines because they want to cut down on the amount of junk food. Junk food just means unhealthy food that students were eating. So Luke is conducting a survey. We can do experiments. That's one type of way of finding information. But another type of scientific method is to do a survey. You ask questions and then you analyze the data to look for a pattern. So he's asking about how much junk food students ate before and how much junk food they eat now. He sends the survey to members of his soccer team, his football team. Many of them used to get a snack from the vending machine after practice. If half of the team members respond to the survey, will Luke have reliable data? Why or why not? Well, the school had vending machines for the whole school. The soccer team is not the whole school. A football team will just be a few people. And you probably know, amongst your friends, some people are very sporting, very active. Other people, they are less active. They might like music or art. They might like to play computer games. They might not like to play sport. People that really want to care about their sport might have a different type of diet to those that don't care. So by only asking the soccer team, his sample is biased because he's not asking a representative sample. He is asking a narrow sample. He's only asking people that played football. And his soccer team, we know that we have male team and female team. They are probably all male, probably no female, because you do not have co-educational football teams. You have male football teams, you have female football teams, but he only asked members of his football team. So he's not asking female students, and he's not asking anybody who did not do sport. So cannot be yes. Even though they might come from a variety of backgrounds, there are a lot of people that would not be included. And some of them use the vending machines, yes, but what about people that do not like sport? What about people that are unhealthy? So no is going to be part of the answer. He did not survey the team members before the vending machines were removed, but he did ask them. He asked them how much they ate before and how much they eat now. Okay, their memory might not be so good, it might not be so accurate, but that's okay. You can ask people what they did last year and what they do now if you're looking for a difference. It is better if you did a survey before and you do a survey after, but it's not always possible because you might not know that you want to research this before this thing happens. So it's not always possible. This is acceptable, but it's not a random sample of the whole population. The whole population of students is male and female, sport player and non-sport player. He is only asking the male sport players. So it is not a good data set. It is not reliable. He cannot make a generalization. He cannot say that what he found is true for all students. He can only say that what he found is true for the male sport students. He would need to add in females and non-sporting students if he wants to make a wider conclusion. Now, the term wave is used to describe any of several different ways in which energy is transferred. Electromagnetic waves transfer energy via electric or magnetic field vibrations. Sound waves transfer energy through vibration of air particles or through the vibration of particles of solid matter. through which they may travel. Water waves transfer energy through the vibration of water particles. So we have three different types. We have the electromagnetic waves, transfer energy via electric or magnetic field vibrations, sound waves through the vibration of air particles, water waves through the vibration of water particles. But regardless of the wave type, the greater the amplitude or distance from the center, the greater the energy. Remember, if we draw a wave like this, and we draw a line through the center, from the crest to the center, or from the center to the trough, is the amplitude. So if the wave is like this, it has a greater amplitude, and so it's got more energy. What can we infer from the passage? Now see, there are only three types of waves known to man. Well, there are several different waves, but these are examples of waves. There can be other waves. These are just examples. So take away answer C. Sound produced by a flute will have more energy than sound produced by a bass drum. That is not supported by the passage. The amount of energy is based on the amplitude. We do not know the amplitude of a flute or a bass drum. So we can take away answer B. So A or D. And both of these are about tsunamis. D, tsunami waves have more energy than all other kinds of waves. Well, that might be not supported. We don't know about all other types of waves. We do know that if the amplitude is greater, then there is more energy. But we don't know about all of the types of waves, so this is probably going to be wrong. A tsunami wave will have more energy than a wave caused by a passing thunderstorm. Now, a tsunami is a very, very strong wave, and you might see pictures of tsunamis when they hit the shore. They can be 10, 15, 20 meters high, and they can cover whole buildings. Normal storms might get a couple of meters high and cover the beach, but normal storms would not raise waves up so high that they cover entire buildings. So a tsunami, which can raise the wave very, very high, which would cover the building when it hits the land, this amplitude would be much higher than the amplitude of a normal wave created in a thunderstorm. So A is the correct answer. Question 34. Put the X on the part of the cycle that could potentially be removed with the least impact. So if there's no precipitation anymore, there's no way for the condensation to go to the ground. That would stop the entire cycle. So we cannot choose precipitation. If there's no groundwater, then there's no way that the water can move along ready for evaporation. So the cycle would continue. But there are two ways for the water to enter the air. There is transpiration from plants, which puts water into the air, and there is evaporation, which also puts water into the air. So which one of these could we remove? If there's two things doing the same job, then one of these could be removed. The best answer is if we remove the transpiration from the plants. Evaporation from the groundwater to evaporation to condensation. This is very important. The transpiration takes a little bit of water from the ground up through the roots and releases a little bit of water after photosynthesis. This is a small part, and we can guess that it's a small part looking at the size of the arrow. This is a small part of the water cycle. Now, in this experiment, 3 of the same plants were grown in identical circumstances. Identical circumstances. The only factors that changed were that one plant was given coffee, one plant was given Miracle-Gro, and the other was given nothing. The plants were then measured. The plants were measured each month to see how tall they were in inches. What was the purpose of the experiment? Well, we're looking at the growth of the plant. There is nothing here about the fruit. In fact, we don't even know what type of plant they are. They could be flowers. If they're flowers, they don't even have any fruit. There is nothing about fruit in either the graph or the passage, so we can take away answer A. And then D, looking at the weather is not mentioned in either the graph or the passage, so we can take away answer D. So we need to choose B or C. To find an alternative to fertilizer, so something that can be used instead of fertilizer, or to see whether coffee or Miracle-Gro could make the plant grow taller. Now, fertilizer is a little bit too broad. We don't know. We're not looking at all fertilizers. We're not looking at all alternatives. We're only looking at two things. We're looking at the Miracle-Gro and we're looking at the coffee. So the purpose of this experiment is to compare Miracle-Gro and coffee and see which one makes the plant grow taller. So the correct answer is C. Now let's just talk about this question a little bit more. You'll see that there is a control here. A control means nothing extra is added. This is what normally happens. So the control line is the one that grows here. So we can see that adding coffee and Miracle-Gro, both of them improve what normally happens. But after 2 months, the coffee plant starts to die or starts to get smaller, but the normal plant would continue to grow. So we can compare the effect of using coffee on the normal and of using the Miracle-Gro on the normal. When we want to know the effect of doing something, we must have a control. If we want to see how effective something is, if we want to know how effective a new medication is, how effective some exercise is, we need to know what is normal. And the normal is the control. So this sometimes comes up. How can we improve the validity of the experiment? We need to add a control group. If you see that kind of answer, it might be the one that you're looking for. If there's no control group in the original design, that would be a flaw, an error in the experimental design. Secondly, let's think about what is the independent variable and the dependent variable of this. Well, when we're looking for the independent variable, we should be thinking about change. So what is changed? One plant has Miracle-Gro, one plant has coffee. This is what is being changed. And we can see the word changed in the passage. So coffee and Miracle-Gro are about change. So this would be the independent variable. When we're looking for a dependent variable, we should be looking for things that are measured. And we can see here the word measure. So this is going to be the dependent variable. Now I'm just going to pause going through these questions for a moment. If we see that X has an effect on Y, well, X will be the independent variable. And Y would be the dependent variable. You can think of X as being the cause and as Y being the effect. As well as that, there are some words that might help you. If you see change, the scientists changed the temperature, then you're looking at the independent variable. If there were different temperatures used, then it's an independent variable. If they're using vary or variety, the scientists used various different positions. The scientists used a variety of different temperatures. These all show you or give you a clue that you are looking at the independent variable. If you see things like measure, So you measure something, or you record something, or you observe, you watch something, or you see the impact. All of these words would show you that you're looking at the dependent variable. I think it would be really good if you just pause the recording now and copy down these words. These will give you a clue in the exam. If you're asked to identify an independent variable or a dependent variable, these words should give you a clue as to what you're looking at. So just briefly pause the recording now. Okay, on to the final question. It's been a long recording, I know, but on to the final question. Victor wants to investigate the effect of different types of exercise on the heartbeat. So he is investigating the effect of different types of exercise on the heartbeat. So the different type of exercise would be the independent variable. The heartbeat would be the dependent variable. We see the different types. So that is giving you a clue that the type of exercise is the independent variable, and it has the effect on something. It is the cause of the change in the heartbeat. So making a hypothesis means predicting what will happen. Designing means planning how to test this. Predicting, guessing what will happen. Collecting the data means doing, and you will normally at this stage be recording, either recording numbers or recording observations, things that you see. And drawing a conclusion would be analysis. Was your hypothesis right or wrong? So Victor performs each activity with a 4-minute break in between to allow the heart rate to return to normal. He records all and calculates the average. So in this one, he is performing, that means he is doing. He is recording, so he is collecting data. So this one should be collecting the data. We'll go across next. Victor thinks that more vigorous exercise will need more energy. This is predicting, this is future tense, because the heart will need to beat more quickly. He thinks, he is planning, he is predicting, he is guessing about what will happen. So this is the hypothesis formation. Victor analyzes the results. Analysis. And he finds that running caused the heart rate to increase, so his hypothesis is proven. He concludes that he was correct. His hypothesis is proven. This is the conclusion. This is what you do at the end of the experiment. Victor selects. He chooses the exercises walking, jogging, and running. He plans. Planning. In the future, he is planning. He's not doing yet. He's still thinking about doing it. He's planning to perform each one 3 times and record the heart rate. So this is designing. Designing always means planning. And this is basically the scientific method. There's sometimes 2 other steps that sometimes are shown. Before you form a hypothesis, you would ask a question, and you might look at what other people already know. And after you make a conclusion, you might share your findings to other people. You might publish. But these are the central steps. After you ask a question, after you find some information, you make a hypothesis, you design a test, you do the test, and then you make a conclusion. And that's the end of this explanation video. Hopefully it's been helpful for you. And there is another exam ready on Moodle when you're free. O sulla sai, Code?